6. Solving logs. So I wrote the steps up last time.
Yeah.
I called it a log countdown, right? Let me do it one more time. So if you have 2 or more logs, so the steps are if what is it? If it's 1 log each side. If it's 1 log each side and nothing else, just cancel the logs by logic, right? We talked about that. But otherwise, get the logs on the same side. Get the logs on the same side, and 2 logs become 1 log by the properties, those special properties we spent time on. Adding becomes multiply, subtraction becomes divide. Step 3, lose the 1 log. I should say lose the 1 log. The base stays the base. Other two switch. And step 4. Back up here, get kind of messy. Other two switch. Lose the 1 log, base is base, other two switch, and then solve and check, right? No zero, no negative inside of a log. Okay, so there's the steps, and I nicknamed it to help the log countdown. Log countdown. So, all right, so when you look at this question, 2 logs, you want to think, all right, I got to count those logs down. It should be 2 logs, 1 log, no logs. That's how the flow should go. 2 logs, 1 log, no logs. So can you do it? What do you do first? You got to take those 2 logs and put them together into 1 log, right? Adding, easy operation for 2 logs, will become a harder operation multiplying for 1 log. Good? So 2 logs become 1 log. There we go. So we don't have step 1 on this problem, because that's if you just have 1 log on each side and they're the same. So good. So 2 logs become 1 log. We're counting down the logs. So 2 logs become 1 log. Next line, we're going to have no log. How do we go to no log? We lose the log, huh? And when you lose 1 log, base stays the base, other two switch. What's the base? 10. So the 10 will stay 10. The other 2, meaning all that x stuff, and the 2 will switch. Instead of 10 to the x stuff, it's 10 to the 2. X stuff goes over there. Good?
I just wait for you to finish.
All right. So 2 logs, 1 log, no log. So now it just says solve it. So okay, 10 squared is 100. Distribute the x. X squared minus 58. Did we do this one?
No. Yes, we did.
We did it. Okay, I'll do it quick. So 100 is x squared minus 15. It seemed awful familiar. So
No, you don't have good memory, Mr. Harris.
I don't, but it's not that bad. All right. So we get to there. All right, and then just move that 100 over, zip over there. X squared minus 15x minus 100. Do the parentheses. What multiplies be 100? 5 and 20, right? Use your calculator, 5 and 20. Sign in the middle goes in the bigger. And so you know it's just opposite sign. You know how it works. So, and then you check them, but the negative 5 would make the inside of the log 0, so the answer is just 20. All right. So there it is. All right. So try that one. First step is to get those logs on the same side. If you look back at the steps I gave, get the logs on the same side. So grab this log and jump him over here. Good for the first step. So get them on the same side. By the way, why can't I just cancel out the log from both sides? We did that a couple
Didn't you
times
say that
yesterday.
was illegal?
What's
You
up?
said that was illegal.
Well, we did it a couple times yesterday. Well, why can't I just do it like that? Why can't I just go boom, boom? Because of the 1. If that 1 wasn't there, and that's what I'm saying with these steps here, I'm saying if there's 1 log on each side and nothing else, then you can just cancel the logs. Right? So if it was just log of 4x plus 7 is log of x minus 4, I would totally just drop the logs, and I would just go to 4x plus 7 equals x minus 4. That would be what I would do. But if there's something, excuse me, something else there, you can't do that. So instead, we have to get the logs on the same side, make the 2 logs into 1 log, start the countdown, right? So we got the 2 logs on the same side. Now you're thinking 2 logs, 1 log, no log, right? So go ahead and do that using the properties. So subtraction, take care of that. So subtraction becomes division, huh? Subtraction becomes division. Good, remember that property? If that was a plus in the middle, then I would make it 4x plus 7 times x minus 4, wouldn't I? You guys with me on that? If it's plus in the middle, it's times. That's what the properties told us. If it's minus in the middle, it's division. Okay, good. So we went from 2 logs to 1 log, and now we got to go to no log, right? Counting down 2 log, 1 log, no log. So now go to no log. And when you cross off the log to go to no log, the base stays the base, the other two switch. What's the base?
10.
Yeah, visible, understood, 10. So the base stays the base, so the 10 will stay 10. The other 2 will switch. Now, what do we mean other 2? Well, all that x stuff and the 1. Instead of 10 to the x stuff, it's 10 to the 1. And the x stuff goes over where the 1 was. Is that good to there? See how we lost the log there? So 2 logs, 1 log, no log. Base stays the base, other 2 swap, 10 to the 1 is all the x stuff. Okay, so now we're up to here, we're like, and 10 to the 1, that's just 10, isn't it? So 10 equals 4x plus 7 over x minus 4. Everybody good to there? So now we've gotten rid of the log, so we're out of the log world, so now we're just into normal solving equations, but this one isn't easy. What do you do when you got like a whole number equaling a fraction? You know, you can just put it over 1 so it looks like a fraction, and then just go diagonal, cross multiply. Seen that before? You know, when you have an equals, you can cross multiply. If you have times in the middle of 2 fractions, that's when you cross cancel, huh? Times in the middle, cross cancel. Equals in the middle, cross multiply. So 10 times x minus 4 is 1 times 4x plus 7. Cross multiply like that. And then just solve for x. Distribute. 10x minus 40, boom, boom. 4x plus 7. We got x on, what do you always do when you have x on opposite sides? We're going to do them first, right? I'm not going to do the 40 and the 7. I'm first going to do the 10x and the 4x. So what do you do when you have x on opposite sides? Just get rid of one of them, right? Doesn't really matter which one. So it gets rid of that one. Kind of bring it down here. What do we have? 6x minus 40 is 7. And then we add the 40. So we've almost got it. 6x is 47. Last step is divide by that 6. There we go. 47/6. Maybe, as long as it doesn't make the inside of any log 0. To check real quick, if you guys have a calculator, you can just divide. It's 7 point something on your calculator. So that means if I plug in a 7 point something right there, 4 times 7 something plus 7 is certainly not negative or 0. Put a 7 something in there, take away 4 is not 0 or negative, so it's good. See how quick the check is? You can just make sure it doesn't make the inside of any log 0 or negative. It's a keeper. So 47/6 is the answer.
We could turn that into decimal or no?
I think they just want the straight
Exact.
fraction. I think.
Could you like that?
You don't believe me again? Well, there's just so much doubting here. 47, I think it's good. I'll let somebody else check it. I'll move on. Number 10. We'll try that one. Same kind of thing. Get the logs on the same side, then count down the logs. 2 logs, 1 log, no log. So jump that log over so we get log base 4x plus 7 plus log base 4 x minus 8 is 2. Like that. And then count down the logs, right? 2 logs, 1 log, no log. So go to 1 log. So when I go to 1 log, is the x plus 7, the x minus 8, they're going to be multiplied or divided? Multiplied, huh? They're going to be multiplied because adding becomes multiply. If there was a subtraction in the middle, it would be divide, right? Okay, so 2 logs, 1 log, no log. So lose the log, base stays the base, other 2 switch, meaning all this x stuff and this 2 switch positions, right? We'll let you do a little bit more. Point out Mr. Roberto is here in the back. He's here. He's checking with us. See, and he already knows how to do all this stuff, but he's just checking in with exactly how we're doing it. So go to him for help if you need help. Great resource. Got a lot of hours back there. Okay, so switch these. Instead of 4 to the x stuff, it's 4 to the 2. Like that. That good? Everybody okay with the log stuff so far? Is that making sense? And that's 16. And then what do you got to do? Over here, you're just going to have to FOIL this out. X squared minus 8x plus 7x minus 56. Like that. And that's 16. X squared was that minus 1x. Minus 56. Good to there so far? We've got rid of all the logs. So what should we do now? Looking at this, what thought should be in our mind?
Work out for x.
Set it equal to 0.
Get a 0, right? Whenever you see x squared with an equal sign, remember the steps. Get a 0, right? You're old pros at that now, right? Factor with the parentheses, and you know the process. So get a 0, huh? So subtract 16 from both sides. What'll give me 0. What is that? Minus 72. Like that. So we always get a 0, huh? Whenever we see x squared, we always get a 0. That's always the game plan. And then factor. And so what's that? 9 and 8? And yeah, whatever sign's in the middle goes in the bigger. And then it ends up being opposite for the final answer, huh? So plus 9 and minus 8, but the minus 8's no good. You can't put in minus 8 here. It'll make that log, inside of that log, negative. The plus 9 is fine. The plus 9 will make that positive, and even 9 minus 8 is positive. So plus 9 is the only answer. Good? Solving those logs? Count down the logs. 2 log, 1 log, no log, and then just, when you got x squared, get a 0. Make sure you check them. Yeah, make sure you check them. Would be a bummer on a multiple choice test to do all that good work. And then like option B or whatever has plus 9 has them both, and you grab that. That would be a bummer, right? Don't do that. So make sure, like, put some kind of note in your 3x5 card. Or you know what, do this. The minute you get the exam in your hand, exam number 3, just, there's certain things just to check for. And this is probably the only thing, just look through the test really quick. Any problem that has a log with an equal sign. We had a bunch of logs, what was it? 2 days ago that didn't have equal signs. It was just like log property questions, like what's the log of x times x plus 3? Make it 2 logs. You know, no equal sign there. Just, oh, you just want me to make it 2? Okay, it's adding. All right, I'm done. You know, we had some of those that didn't have logs without equal signs. I'm not talking about those. Those don't need to be checked. But any log with an equal sign, and there's only going to be maybe 2 or 3 on the test. So if you just look through the test real quick when you get it, whenever that is, a couple weeks from now, and just when you get to that problem, just circle the question or just put a C or a check mark or something on it. Right, you know, first 10 seconds you get the test in your hand. Just look through it real quick, put a little mark there, and go, okay, when I get to that one, I'm going to check the answers, because for negative answers, you have some kind of game plan like that. Super quick, because I want to make sure you're not confused by the E thing. Oops, come on, there we go. So ln x plus ln x plus, and I'm just going to whip it out. So 2 logs, make it 1 log, adding becomes times. Okay, and then lose the log. So, you know, counting down logs, 2 logs, 1 log, no log. When you lose the log, the base is e, as you know, and so what happens? The base stays the base, the other 2 swap, so the e will stay where it's at. Instead of e to the x stuff, it's e to the 4, and the x stuff goes, oh no, that is ugly.
You're going to get a radical at the end.
Oh yeah, we better do this one. Okay, I'll slow down. Yeah, this is weirder than I thought.
I'll just
All
wait
right.
for you.
And then like you can't factor the e because e represents c later on, and then you'll have to use the quadratic formula. to
Right.
qualify.
Right. Yeah, we better do it. Okay, you good to there? It's gonna get a little weird here.
That's like a big stop sign, what she said. Like, I gotta stop writing. You just wait.
So Barbara, you were telling me to skip it though, and you knew all this? I don't know if I can trust you now.
I thought it was like.
You're just like, I know this, so just go on.
Just read the little example. You're like,
Just
oh,
read
that's
the
right.
yes to it. Show me example helps. Yeah. So good to there? It is a little confusing. I want to point out. Remember that e to the 4th is just a number. That's I think the main thing that confuses people because really it's a letter. I mean, you're like, what do you mean it's a number? It's a letter. Yeah, but it's like pi. You know, it represents a number. It's not an x. In other words, it's just a number. That's going to be my c. Well, when I move it over. So well, I'm going too fast. Everybody good to hear, right? So 2 logs, 1 log, no log. And now when you see x squared, what are you supposed to do first? Get a 0. Always the game plan. So just jump this or subtract it. Same thing. To the other side becomes minus e to the 4th. And again, remember, it's just a number. It's some number. E's 2 point whatever to the 4th power. Some number. So quadratic formula. A is 1. B is 10. See, now why quad? Because it won't factor. You can't factor e to the 4th. You know what I mean? When you have x squared, you guys know the game plan, right? Let me write it again. When you have x squared with an equal sign, step 1 again is get a 0. Step 2 is try to factor. And if you cannot factor, then you do the quad. Negative b plus or minus the square root of b squared minus 4ac all over 2a. That's what we have to do. Why? Because you can't factor with a weird old e to the 4th in there. You can't factor. So we're going to have to do the quadratic formula. Is that good? You got that copy? Now I'm going to go to fresh screen and rewrite that. So I've got 0 is x squared, what was it? Plus 10x minus e to the 4th. Right, to there. And so I'm going to use the quadratic formula now, which is x equals negative b plus or minus the square root of b squared minus 4ac all over 2. And yeah, like Barbara's saying, the a is 1, the b is 10, and the c is the negative e to the 4th. That whole negative e to the 4th is c. It's kind of weird. We're not used to a c like that. But it is a number. It is a number. Right? The a, b, and c are always numbers. They're not the x's. So it's valid. So, although it's weird. So negative b, negative 10, plus or minus square root of b squared, 10 squared minus 4 times a times c all over 2a. What's that? Plus 4 e to the 4th over 2. We get to there so far. See why I got plus? Negative times positive times negative, 2 negatives, positive. Good so far? Now, it would be nice if we could just square root that 100 and make it 10, and that 4e to the 4th and make it like 2e squared, but we cannot because of the plus sign. You know, it's plus and minuses just wreck everything. All the nice stuff. So it's just good if you have, you know, this is advanced algebra. You guys are getting better and better at algebra. One rule that'll help in a million situations is pluses and minuses, nothing nice can ever be done. Really, that's pretty much true. So in other words, if that was times, if right here in the middle, this was times instead of plus or minus, you could totally do this. It'd be 10 times, you know, that'd be totally valid and right thing to do. You could just root them. But the plus and minuses, they like glue things together, as we've said, and they wreck all the nice little shortcut rules. So you can't do that because this is all like glued together. You can't treat the 100 separately and treat the 4 separately. You can't. What do you do then? You just leave it. I mean, you can't really do anything with it. But you can factor. Good. Yeah, this is tricky. Good job, Barbara. Yeah, you can factor. I didn't even notice that at first. You're right. Take out the 4 there. Why does factor work? Because then it makes it times. You see how that changes it from adding to times? And times we can do things with. So this will be 25 plus e to the 4th over 2. Everybody good to there so far? This one's going to have some wrinkles. I see it coming now. All right, now I can root that 4. Why? Because it's timesed, you see. It's not added or subtracted. So you can root the 4. So it'll become negative 10 plus, and what's the root of 4? 2. So that comes out of the root as a 2. Everybody good to there so far? See what happened? We factored the 4 out of these. Again, you can't just root the 100, root the 4, because the plus sign glues them together. But you can factor. That's why we're so into factoring, because factoring turns things into times, and all the rules for times are easy. Probably you see a little deeper now into why we're into factoring so much, because it makes it times, and times rules are easy. Square root of 4 is just 2 now. But we can't, again, we can't square root of 25 though. Can't make that 5 because of the plus, and we're just done with that part. Anyway, now can I cancel? Can I go like that?
Yes.
Only if you do both. Because remember, plus and minus glue. Costco package, as long as you do both, make that negative 5 and that 1, it's okay. Now, if only one, like if this was like a 9 out here or something, two couldn't go in, then I couldn't do anything at all. It's all or nothing. When things are plus or minus, it's both or nothing for dividing, right? So I can do both, though. 2 goes into 10 and into 2, so you get negative 5 plus or minus 1, root of 25 plus e to the 4th. Getting a little scribbly there. This is messy. I didn't realize how messy this was. So there we go. Now,
2 radicals, but the positive.
yeah, if you go back, I'm getting tired of this problem now. Right here, remember, we got to check. All logs must be checked. You can't plug anything into a log that would make the inside of the log negative or 0. Well, this is 2 answers, really. Do you realize this is negative 5 plus, you don't need the 1, root of 25 plus e to the 4th, and negative 5 minus root of 25 plus e to the 4th. You can check with your calculator. That one's going to be a negative answer. You can see the negative sign there. So the answer is only the plus version in the middle. That's the only valid one. That one's a positive number. You can tell it's positive. Well, are you tired of fooling with it? Square root of 25 is 5. I know I can't root just it, but that still is more than, this is more than 25 in here. So the root of it is more than 5. So subtract 5. This is positive. Anyway, you can do your calculator. You can tell it's positive. So there we go. There we go. That was a messy one. Is that okay? Questions on all that? Algebra maneuvers?
It's also the same thing, but it's a little bit different.
Such a long section. All right, they're getting long on us. So, count down the logs. So we got 2 logs. I'm going to go straight to 1 log. That's okay. The base is a 5th. There's a minus in the middle. So what am I going to do when I go from 2 logs to 1 log? Divide. Right? Because subtraction becomes division. Good so far? Went from 2 logs to 1 log, right? 2 logs subtracted is 1 log divided. Is that good there? And then we lose the log. Right? 2 logs, 1 log, no log. Lose the log. Base stays the base. Who's the base? That 1/5. So that, I don't know where to put it. That 1/5 will continue to be. The other 2 will switch. What do you mean other 2? All that x stuff and the negative 1. Instead of 1/5 to all that x stuff, it's 1/5 to the negative 1. And all that x stuff goes to the other side. Does that make sense? That's the same maneuver we always do. It just looks a little weird with all those fractions. Is that okay? So, right, 2 logs, 1 log, right, 2 logs subtracted, 1 log divided. Then lose the log, base is base, other two switch, 1/5 to the, and what's 1/5 to the negative 1?
Positive 5, right?
Regular 5, positive regular 5, right? Because negative powers flip things, don't they? They don't change signs, they flip. So that's 5. Okay, and now what am I going to do to solve this thing?
Multiply by the bottom.
Yeah, put it over 1, diagonal, cross multiply. Bring it over here. 5 times x squared minus x, 1 times x squared plus x. That good to there. Like that, then we distribute. 5x squared minus 5x, distribute 1x squared plus 1x. We see x squared. What's our game plan?
Get all that to one side.
Get a 0, which means get everything to one side. Exactly. Is that good? Whenever x squared rears its ugly head, we get a 0. Get a 0, right? So to get, I'm going to get this side 0. Boom, boom. That side 0. What's the other side? 4x squared minus 6x. Yeah. Is that good to there? We're close.
Factor the x.
Yeah, factor out x or 2x, whatever you want to do. Good to there? Maybe I can finish it up. Get this out of the way. Right here. Yeah, you can just factor out. You can factor x or 2x, whatever you want. Be 2x. It'll work either way, minus 3. Because that would multiply to 4x squared minus 6x. And then set each part that has an x equal to 0, right? If two things are times need to be 0, either one can be 0 to make that happen. Divide by 2, so x is 0. Move the 3 over. Positive 3 divided by 2. Positive 3. So 0 or positive 3 halves, not the 0. Throw away the 0. Because if you put in 0, it makes the inside of that log 0. Not allowed. But the positive 3 halves is good. So positive 3 halves is the answer, the only answer.
Oh.
Is that okay? Log equations. I better move on. It'll be on YouTube if that was a little bit here. Let me, they're all a little different. They are. 2 logs on this side. Make it, let me show you a trick. Make it 1 log. Right? So, x minus 8 over x plus 1. Dividing, right? Because subtraction. Same thing on the other side. Make it 1 log on the other side as well, against subtraction dividing, and then by. Remember step 1, when you have the same log on both sides and nothing else, nothing outside of them, drop them by logic, right? If the log base a of this equals log base a of that, well, those plugins must be equal. They must be. Or how would log of one of them equal log of other if they were different? So x minus 8 over x plus 1 must equal x minus 3 over x plus 4. So that's how I got, so I did it a little different this time. I got rid of the logs by just making both logs the same on both sides and then dropping them by logic. Is that good? And then you go diagonal. And I'm going to go dot. This one will be nice. It'll be x squared, but the x squared will drop out. It'll just be regular x. You get an answer, and maybe it's no solution, Barbara says. So I just wanted to show you those first 2 steps. Right? So next step would be x minus 8, x plus 4, x plus 1, x minus 3. And then you FOIL this out. You're going to get, I'm just going to skip to it, minus 32, x squared, minus 2x minus 3. Then you're going to drop x squared out of both sides. Like that. Then just solve for x. I don't know what that is. 2x is something like, add 3, what's that, minus 29. Minus 29 halves, I think, is the answer. But that's not right. That's not allowed.
Yeah, that's negative.
Cross that out, no solution. It's not just that the answer's negative is the problem. It's that plugged in, it makes the inside of a log negative. You can have negative answers. Everybody hearing me on that? You can have a negative answer. For example, if I had a log of 3 minus x, and I got the answer x equals negative 2, that'd be valid. Because put in that negative 2 there, that's 3 minus 2, that's positive 5 in there, that's okay. So you can have a negative answer. You just can't make the inside of a log negative, or 0, right? Anybody seen the difference? So this answer is no good, negative 29 halves. Not just because he's negative, but because of the fact that if you put him in, say, right there, negative 29 halves minus 3, that's for sure something negative. I don't know what it is, but it's a negative minus a negative. It's negative and negative. Well, that sounds funny. Yeah, it's something negative, subtract some more. So it's negative. So it's no good. No solution. Okay, so 2 to the x is 7. So x in power. What do? Number 1, try to make the bases the same. But you can't make those two bases the same, can you? So if you cannot, L in both sides. Did we talk about that? Yeah, we did. I did the whole stories of Hitler, Stalin, all that stuff. Right? Get the x out of power. Just get the x out of power. L in both sides, right? Did we talk about that?
Yeah, but does it have to be ln, or can it be log?
It can be regular log too. Either one's fine. So I'm just going to do L in both sides on that. That's right. So this isn't new. We don't need to go all slow and everything. And then it lets that x come down. That's that property 3, huh? We kind of started doing that one ahead of time, so we're comfortable with that already, right? Property 3 says powers. It dethrones powers. That's why it's a good way to go, because it gets that x out of power. So that's x in power that we do this. And now that x is just down on the base level, it's not a big problem. It's not a big problem. Just divide by L into. Boom, there it is. Is that good? What's that? I think they want it just like that. Yeah, they say exact solution. They don't want a decimal. Want it just like that.
Wait. Oh, okay. Yeah. This is
3 times 2 to the 8x is 5. So, okay. So, yeah, let me add one more step then. X in power, step 1. Get the base alone. Get the base alone, and then L in both sides. So, yeah, notice I'm going to divide by that 3 first. You want to get that 3 out of there first. And then you have 2 to the 8x is 5/3. And then L in both sides. Yeah, so first get the base, which has the power on it, alone, you know. So I got that 2 to the 8x alone first off. You don't want the other stuff there, because that'll mess up your Ln, to have something else there also. You want just a clean base and power, and then Ln, and the power comes down. So now that 8x will come down. 8x Ln 2, this is just Ln 5/3, whatever that is. And then how do I finish solving for x? Well, now that the x is out of power, I just, on the way to work this very morning, I told you I listened to Churchill's biography. They did the part where they made the whole movie with Tom Cruise. What was it? Valkyrie, and he tried to kill Hitler,
Assassinate Hitler.
right? I heard it just this morning after Colonel Von whatever. That was very real. I can't remember what his name is, and he tried. The problem is I didn't know in the movie that he had 2 bombs, and his hands were broken. He could only do 1 bomb.
His hand got blown off from
the right. Anyway, well, I get it. Yeah. So I'll get into history, and I'll never stop. All right, let's keep going. So anyway, so they wanted to get Hitler out of power, right? So we're getting the x out of power. So I am trying to teach a math lesson. So when x is in power, that's why you do Ln. Once you get it out of power, like they're trying to get Hitler out of power, once you get the x out of power, it's cake, huh? When x is down on the base level, no big deal at all. Then just divide. Just divide, huh? It's no big deal at all. It's all about getting that x out of the power. Then it's easy to deal with it. This is our answer. Just type it in just like that. That good? On that? All right.
the word problem
Okay.
with population and growth.
Okay, thanks for the heads up. Okay, so 22, 27, I'll make sure we look at those. Okay, let's look at this. Okay, it's the same thing. X is in power, Hitler's in power, trying to get him out of power. L in both sides. L in both sides. So let's do that. So the x comes down, the whole 1 minus 7x comes down. We get to there, so that's That's the great quality of the ln. It dethrones the powers, brings the powers down. Now, this is a little messy. Let me help at this point. This, I know semesters past, this is hard for people usually at this point. Remember, ln2 is just a number. Don't let that throw you in any way. It's just, you can get it on you, we're not going to get the decimal, but just know it's just a number. And so is ln3. So this is just a number. This, you know, like, what would you do if you just had a 5 out here? What would you do? You would just distribute it, right? It's exactly what I'll do with the ln2. Remember, it's just a number. So just distribute. So ln2 times 1 is just ln2. And then ln2 times 7x is just 7 ln2. You know, just do it that way. You don't have to put parentheses, but that might help you to see it. It's just a number times x. And then this over here, in fact, I'll put the ln3 in the front. You don't have to, but I just want you to see it's just a number. It's just a number. We good so far? Those are just numbers, right? I just distributed the ln2 times the 1 times the 7x. Okay, now we have x in 2 locations. We had this previously, but it's never easy. What do you do when x is in 2 spots? Get them on the same side, factor the x out, and divide. Very important. It comes up a lot in calculus. So get x's same side, factor out x, and divide. Yeah, you want to know that. Comes up a lot. So that means this term and this term, I want to get them on the same side. Factor out the x and divide. So I'll just jump this to the other side. So then we'll have ln2 is ln3x plus 7 ln2x. Good so far? Let me bring it over. Well, let me factor out the x now. ln3. And you don't need, if these parentheses are confusing, you take them off. You don't need them. I'm trying to be more clear, but maybe they're more confusing. Take them off if they're bugging you. You don't need them at all. Not required. Maybe just better leave it like that. 7 ln2. Is that good? I just factored out the x there.
And then divide by that.
And then just divide by that whole chunk, yeah. Just divide by that whole ln3 plus 7 ln2. Both sides, of course, right? ln3 plus 7 ln2. Boom. So this, all, big mess, is the answer. That's a hard one.
Does it matter what you divide by the other?
Which-
So like, what if you divide x times all that by ln over 2? Does it matter?
One more time, Trey?
If you do, what if you switch divisions? Like switch the product?
What if you divide?
Divide by ln2?
Yeah.
No, I got to get x alone.
Oh.
So I got to get rid of whatever's with x. On that, yeah, I got to divide by what's next to x to get x alone. So it's got to be that way. That good?
And this is the Thursday?
Yeah.
Tomorrow.
Okay, so pi to the 1 minus x, e to the 7x. What am I going to do? ln both sides, right? Get Hitler out of power. So bring down the powers. So 1 minus x ln pi, 7x ln e. And what's the ln e?
1.
Yeah, that's just 1, so we can just ignore that. Good so far? So again, when x is in power, Hitler's in power, get him out of power, ln. All right, and then distribute. So ln pi minus x ln pi is 7x. We good to there? You got the parentheses, just distribute. And what should we do now? It's all about kind of like recipes. Like, what are we looking at? Identification. You want to look at it and go, this is this type. What type? It's the x in 2 spots type. So, x in 2 spots. That's why I keep writing these steps. So I want to help you identify. When you see a certain thing, these are the steps. You want to put these kind of things in your 3x5 card. When you see x in 2 spots, you get the x's on the same side, factor out the x and divide. So get these x's on the same side, jump this over here, get both those on the same side, plus x ln pi, and then factor out the x, like that, and divide, divide both sides there, pi 7 plus ln pi. Boom, x is ln. Yeah, we always have to divide by whatever is next to x. That's our answer. Can I cancel these ln pi's? Because of the plus sign, the glue, you know. So there we go. Is that good?
You should jump to 27.
So you don't miss it. See how they're saying graphing utility? No, just use your graphing calculator. Why? Because they're different bases. We can't do different bases with our formulas. So we have to use the graphing calculator. So how do you actually do it? I would let y1 equal the log of x plus 1 divided by the log of 4. Remember, the high goes high, the low goes low? Minus the log of x minus 2 divided by the log of 2. And I would let y2 be 3. So write the y1 is the left side, y2 is the right side, and do the intersect routine on your calculator.
Under second calc.
Remember, I divided them? Hold on, two good minutes. We got to use those. So dividing here, and dividing here because one log can become 2. All right, you know that whole thing?
Just first curve, second curve.
Yeah. Y1 is the left side, y2 is the right side, and do the intersect thing. Remember the intersect thing? Use your calculator. Here. Anyway, I don't know if it'll be something good
I can pack up.
or helpful.
That's good too.
Population of a certain country in 2000 was 286 million. In addition, the population of the country was growing at a rate of that. Assuming, okay, whatever, they give me an equation, so I don't care about all that other stuff. According, when is it 324 million? Oh, okay. So basically, so they give me this P formula, 286, 1.011 to the T minus 2,000. Okay, and they say, when's the population 324? All I care is that's P. So they want me to put that in for P. They're just saying, hey, make P 324. And they said, when? Find T. So I just have to solve that equation for T. How do you solve that for T? Hitler's in power, right? So what are you going to do? Get him out of power. First get the base alone, though. So first divide by the 286. You with me?
Yeah.
Get whatever that decimal is. And then your friend that gets Hitler out of power, the ln of both sides, bring down the power, and away you go. Is that good? All right, guys.